I want us to do 1, do 3, and do 5. The question is to find the derivative of each of those guys. Let me give you a few moments to do that, and then I'll go over it with you. So when we go to find G prime, we use the fundamental theorem of calculus part 1. All you do is you write the integrand, but you replace the t's with x's. So this becomes square root of x plus x cubed. And that's it, you're done. Is there any questions about that? So there is no difference, Stephanie, between lowercase g and uppercase g. This is just the name of the function. So your book likes to use uppercase for a lot of stuff, but I kind of mixed up the letters because it's just a name. Let's take a look at number 3. If you look at number 3, calculate capital F prime of x. It's the same thing. We got to do one extra thing. We need to interchange the limits of integration. So maybe I'll write an extra step here. I'll put this is equal to negative integral from 0 to x square root of 1 plus secant of t dt. Now, when you take the derivative, it's going to be negative square root of 1 plus secant of t, x, oops, of x. Does that make sense? And then for this number 5 here, we need to use the chain rule because of this thing right there. I think it's easier if you rewrite that as x to the negative 1. Then when we take the derivative of h prime of x, that's going to be sine to the 4th power. We replace the t with the x to the negative 1. We're going to multiply by the derivative of the inside. That's going to be negative x to the negative 2. Put that in parentheses so people don't think it's subtraction. Is there any questions about that? So here's what I'm going to do. I guess the first thing I'm going to do is I'm going to take y, I'm going to split into 2 pieces, 5x plus 12 to 0, secant t tangent t dt, and then I'm going to go from 0 to sine x, secant t tangent t dt. And then I'm going to flip it. So I think the easiest thing is if I just copy the whole thing. Paste this thing down here. And then I could just erase these guys, flip them. So here's 0, here's 5x plus 12, but then pick up a negative sign. Now I can actually start the problem once I've rewritten it. So this is dy dx, or sorry, dy dx, yes. It's going to be negative secant of 5x plus 12, tangent of 5x plus 12. I have to multiply by the derivative of 5x plus 12, which is just times 5, plus secant of sine x, tangent of sine x, times the derivative of sine, which is cosine of x. So that is going to be our answer. Is there any questions about this, my friends? So we got this, and we got this. I'm going to highlight in orange. We picked up a negative sign. So I'm going to highlight in orange. We're going to pick up a negative sign because we interchange the limits of integration. We pick up a 5 because we use the chain rule. We pick up a cosine x because we use the chain rule. So that's it.